Let's go over example 9.2 found on page 382. It says the reaction of tellbutyl bromide with this anion, the N3, using methanol as the solvent, is an SN1 reaction. What happens to the rate of the reaction if the concentration of N3 minus is double? But let's see what N3 anion is. This is playing the role of the nucleophile. And the question is telling you that it's an SN1 reaction, meaning that the rate law only depends on the concentration of the haloalkane and not on the concentration of the nucleophile. Why? Because the nucleophile does not participate in the rate determining step for the SN1 reaction mechanism. Only the haloalkane does, because the rate determining step for the SN1 reaction is the formation of the carbocation. Again, the nucleophile does not participate in the rate determining step for the SN1 reaction. That's why we do not include the concentration of the nucleophile for the rate law of the SN1 reaction. So if you increase the concentration of your nucleophile, then the rate will not be affected because the concentration of the nucleophile is not part of the rate law for the SN1 reaction. Meaning, if you increase the concentration of your nucleophile, the rate will remain the same, because the nucleophile concentration does not appear in the rate equation for SN1 reaction. Let's take a look at question number 9. And for question number 9, we have to go over problem 9.2 found on the same page. That problem says the reaction of bromomethane with the same anion that we used for the example, using methanol as the solvent, is SN2 reaction. What happens to the rate of the reaction if the concentration of the N3 anion is double? Well, it's telling you that it's SN2 reaction, and that's all you need to know, because the rate law for the SN2 reaction depends on both, on the concentration of the haloalkane and the concentration of the nucleophile, because they both take part in the rate determining step for the SN2 reaction. Meaning, if you increase the concentration of the nucleophile, in this problem, this is the nucleophile, then you will also increase the rate of the reaction. In this problem, they're telling you that the concentration of the nucleophile is double. And because of this, the rate will also double.